Welcome to another video of time series 1. Now consider here I have defined the years from 2012, that is 2012 to 2009, and another associated variable is cells. I have defined these cells into only numbers. I have not used any unit, that is thousand or crores. I have not mentioned. I am going to define with the cells values itself. Okay, now to go for time series we will go for data analysis. Data analysis tool is in data analysis. Go for exponential smoothing. Okay, now we have to define the input range. So input range is going to define with only these cells values. Okay, then damping factor, instead of 1 I am going to put as 0.3 here. Okay, which is defined for general define 1. Now we will have this as output over here. We can change the output also. Now chart outputs and standard errors, just by clicking OK we will have this as a values and exponential smoothing. Here we have defined the exponential smoothings also. These are data points and values and this exponential smoothing. So instead of data points we can put, or we can use this as a 2012, 13, 14, 15, 16, 17 and all. Okay, here these values are smooth values which can be defined with the help of moving averages also. Okay, so here instead of you using trend line, or here they are the trend line, add actual based on series, actual and forecast. I am going to use the forecast one. Okay, this is the linear forecast. As you can change or you can just cancel it also. Just go for this trend line. These are the values and right click. These are the forecast one. Time series forecast. Year series actual one. Again go for polynomial one. Select up to order, which will be first. To select order you have to display the equation on that chart, as the equation of that order is already been defined with order 2. Just higher the order. Now along with the equation we have to define our square value also. I am going to put this values or this chart little above so that we can understand, or little down so that we can understand. Okay, so here this is first value is trend line and another one is r square. Okay, so next I can change this linear equations. To go for this chart line, again you have to select that option. Now polynomial, we have order 2. Now go for order 3, which will be more like to that equation. Again display it on the this one. I'm going to erase the polynomial so that we can just This is the equation. Now display equation on the chart, display r square also. Here r square value is 0.8. If I raise the equation up to fourth, your r square value is going to be, now this one is r square is 1, but the shape of that line is going to change. Now how to check the shape? Just I am putting it with the another color so that you can understand. Let it be this one. This one is the equation of raised to fifth order. So this one is not appropriate. Still we are having r square is 1, but this one is not appropriate because actual shape was with blue line and this equation trend line is not same with this. So I am going to delete that equation. Now just go to this equation. ये equation है of order 3. Now just consider the shape of this line which is defined with the black and this blue. Now this forecast and the actual trend line both are having same coincidence. Now here we can put our display equation and r square also. As we are having r square at 0.96, our equation is also going to be same one. Okay, so this is what our time series by using graph. Now here along with that exponential smoothing part, we are going to have this NA and all these outputs. So in this first column, first is nothing but the smoothing level, and in this second I have defined standard errors also. So this one is going to be standard errors. This one is standard errors. Now this smoothing levels, how they have calculated, just consider moving average, so exponential smoothing can be calculated with the help of formula, as first value cannot be calculated and the last value cannot be calculated. Here we have used this formula, that is consider this one. Another one here, just use summation of this one, 1 plus 2 plus 3 is equal to 1 plus 3, enter, and this value is equal to this value divided by 3. Just consider this one is 244, and as we have used the doping factor of 0.3, by this formula they have used this smoothing level. Okay, and standard errors are nothing but the variation of actual values to the predicted value. That means here this smoothing levels has been calculated with 257, 308 and this one. So only 3 values has been calculated. Just consider square root of sum of x, mi and all. Now if you go for this one, the formula has been already been defined. Okay, so 297 ये आया कहाँ से? 0.7 into 0 b4 means this value b4 and 0.3 into f3. f3 is what? f3 is this one, this value. First value taken is as it is. Now go for this one. Next, Now go for next. 0.7 into B5, B5 is this value, plus 0.3 into F4. This value is increasing up to smoothing factor. Okay, that's why while smoothing, first value and the last value cannot be calculated. Now just consider here, this value is SQRT. SQRT is a square root of sum into my2 b4 to b6, b4 to b6 and f3 to f5, f3 to f5. Just if you collect this one, then these two boxes which are being defined has been, go for it. Okay, now the same formula they are going to apply in the previous value also, but in this previous value, first value has not been calculated, means f1 or f2 to f4 is been not calculated. That's why this value for first to fourth is not calculated. The standard errors are not been calculated. Okay, so this is how we are going to use the exponential smoothing command for time series.